Okay, so moving on with page I notes. This is where, in my opinion, calculus gets fun because these rules are going to be the backbone of all the applications we'll do later. And some of them have quirky little catchphrases. So we've had our power rule, we've had the constant multiple rule, we've talked about derivative of sine and cosine, and now we're going to move into some other rules for derivatives. The product rule. So if we are given something as review, f of x equals h of x plus g of x, when we find the derivative of this sum, we just use the sum derivative rule. So f prime of x is just equal to h prime of x plus g prime of x. So that's review. I think I'm going to use a different colored marker. A little hard to see. And then here is our constant multiple rule. So if we need to find f prime of this function here, f prime of x, I still don't like that color, we will go with this pen right here, is equal to, because we have a 5, a coefficient in front, we're going to keep the 5, and then it's times the derivative of g of x, then minus 0, because the derivative of 3 at constant is just 0. So as a warm-up, there are 2 review derivatives. But what happens when we have a product? G of x times h of x. How do we find f prime of x? So according to our textbook, our product rule, when we do product rule, I'm going to write it a couple different ways. If you're given in function notation, the rule is you're going to do the first one, as is, times the derivative of the second one. And then to that, you're going to add the second function, as is, times the derivative of the first. Some other ways you might see that is in terms of u and v. So let's say we are given something like, if I need you to find the derivative of u times v. So some textbooks will not use the function notation, but consider the 2 pieces to the product or the 2 factors as u and v. So you could see, no pun intended, u times v prime plus v times u prime. So it's the same thing, it's just we've got some different variables. I am going to kind of write down a little catchphrase. So here's our kind of catchphrase idea. I think of it like 1 times d2 plus 2 d1. So what I mean by that is you take the first one times the derivative of the second one plus the second one times the derivative of the first one. So you'll hear people say 1d2 plus 2d1. We only take, what would I want to do here? We only take blank derivative at a time in calculus. Oh, so for right now, one derivative at a time in calculus. We write the product rule, which this right here is what I have up here. So let's talk about some examples. Moving to the examples, we have a product now of 2 separate functions, f and g. So when we find f prime of x, I'm just going to say the phrase, I'm going to label this 1 and this 2. So it is a product. So I'm going to say 1 d2, because derivative of sine is cosine, plus 2, and then derivative of the first, shortcut, power rule, 2x. And believe it or not, that problem is done. So you are just practicing this rule. Think of it like this formula here, or using these variables, or that catchy phrase. All right, so now example 2, what I'm going to do here, though, is I am going to rewrite this first. Let's kind of get some room up here. G of x is actually equal to cosine of x. And then what I'm going to do is I'm going to multiply that by, I'm going to bring this up to the numerator, which means that I'll have x to the negative 1/2. So now I have a 1 and I have a 2. So when I do the derivative, g prime of x, using my product rule, 1 d2, I'm just going to keep using the blue. When I subtract 2 over 2, this is like a little side note, negative 3 halves. So I did 1 d2 plus 2 d1. My derivative of cosine is negative sine. Make sure you've got the negative in there. I'm kind of off the screen again. Make sure you have the negative in there. It does not say anything other than find the derivative. So you don't need to simplify anything by making positive exponents. You can, your teacher may require it. If that is the case, you can rewrite this, and this is probably how it'll be in the textbook. When I rewrite this, this is going to be cosine x up here, then 2 and x to the 3 halves by bringing it down to the denominator. Then I'm going to have a minus sign, and then I have x to the 1 half. You could keep going and finding a common denominator, but I want you to recognize that these two are equivalent. The power of equivalency is really important. Okay, moving on to some other applications of the product rule. So going to the top of the next page, here's example 3. So if we're given a function at 2 is 3, and then the first derivative at 2 is negative 3, what we need to find is h prime of 2, given h is this. These are very popular also on the AP exam. So I'm going to start with my h of x function. Because I need to find this, I am going to find the derivative using my product rule. So h prime of x is 1 d2. I don't have an actual expression for f, so I'm just going to write f prime of x. We just did 1 d2 plus 2, and then the derivative of x to the third using the power rule, 3x squared. Now I need to evaluate, okay, h prime of 2. H prime of 2 is 2 to the third times f prime of 2 plus f of 2 times 3 times 2 squared. And then I'm going to keep simplifying. 2 to the third we know is 8. F prime of 2 is given probably up here somewhere. Here's f prime of 2, negative 3. Then to that I'm going to add f of 2. F of 2 is 3. And then 4 times 3, 12. So I'm going to have negative 24 plus 36. That is going to give me 12. Hopefully for an answer. I'll check my answers after I get through all of this. Okay, so example 4 says